we'll start over with the diagram because we already talked about the midpoint a little bit yesterday, so I'm not going to go through everything there. Unless you totally forget, right? Midpoint's just in the middle. Good with that? Okay. If you want to fill in the little things that are on that bottom left-hand side of that page 9, since we're talking about a coordinate plane, right? Everyone should have seen those from algebra, correct? The XY axis, right? You got 4 quadrants there, starting with the right, your 4 quadrants, starting with start right here, right? This is quadrant 1, 2, 3, that was 4, right? And in terms of points, all the points in this quadrant had your x and y coordinates were both positive. Over here, right, your x, y coordinates, the first number that was negative, that's positive. Here they're both negative, and over here, that's positive and that's negative. So if you're filling in the blanks here, you had divided into 4 regions, quadrants, right? The horizontal line is your x-axis, the vertical is your y-axis. Okay, now, so we'll do that problem just to start with here, because it kind of gets you into making sure you can pull ordered pairs correctly, numerically, and trying to reason out some kind of midpoint formula before we actually put it up there. You should have seen this in algebra, so if you remember it, you're better off. Or this should be pretty easy for you. Again, guys, if anyone else needs to move up closer, you can. You want to sit at lab desk, you can for notes and stuff. That's fine. Okay, so starting with point A here, where it says your ordered pair. So now remember that's the x-coordinate and the y-coordinate. So remember the first number that comes in there, your x, is just how far that this point sits over on the x-axis. So if you drew a line vertically to the x-axis, it's going to hit -2. So I know that's my x-coordinate. If you draw a line horizontally over to the y-axis, my second number, that'd be -4. So -2, -4 should be what point A is. Is that okay? Hopefully you remember that. Should be stuff that's in your head somewhere. Whether or not you remember it fresh like that, it's different, but it should be clicking back in. Okay, so we did the same thing with B. What's the coordinate for B there?
1, 5.
Anyone disagree, or is that okay? That should be good. All right? How do you think we're going to find the midpoint? Midpoint's in the middle, right? What do you think?
Subtracting them from each other.
Think? I don't know. Think subtracting? No? What?
Slope.
Yes, no? You do what?
Slope.
You could maybe use that? Yeah.
Don't you do -2 plus 1 over 2, and then -4 plus 5 over 2?
Okay, yeah, that's like using the formula part. Okay, if you do it graphically, you could also take just your 2 distances, meaning that, let's say I created like a right triangle here. Okay, I know to go from point A to point B, I have to go, what is that, 3 spaces to the right, so 3 spaces horizontally. And to go up, I have to go,
9.
is it 9?
Yeah.
I have to go 9 up. So if I want to hit somewhere in the middle, I got to cut those in half. So it means I got to go 1.5 over, and then 4.5 up, wherever the heck that hits me. Should be like right here, maybe. Okay. So if I take half those 2 distances, I will get to the midpoint. All right, which should be right there, which is, what is it? Oh my gosh, -0.5.
Yeah.
It's like -1/2, +1/2. Okay, now the whole point of that is that does lead you into midpoint formula. What's your name?
Tanner.
What Tanner just said was, if you take the 2, you tell them you added them together, correct?
Mm-hmm.
Yeah. So if you take your 2 coordinates and you add those together, meaning that like if I took point A and point B, and I added those two coordinates together, those 2 points, I would get -2 plus 1 is -1, and -4 plus 5 is positive. But again, if you take the middle of any two numbers, like if I just gave you two numbers, like here's 10 and here's 28, and I said, what's the middle of that? You would add them up and then divide by 2, correct? Same thing here. So you're going to add your coordinates together and then divide it by 2. So that's why those become the 1/2. All right? If you flip the page, if you want to write it down, I think there's a place for you to do like the midpoint formula. It's got coordinates like x1, y1, y2, and all that stuff. Your actual midpoint formula, the way it's going to look is essentially what I said there. You're going to add the 2 points together, okay? So the points that they have on that picture that's on page 10 there, this is x1 and x1, y1, and x2 and y2. You're going to add your x coordinates together and divide it by 2. Add your y's together, divide by 2. The order you add them in doesn't matter as long as you group the x's together and the y's. Because I can add numbers in either direction and it doesn't change the outcome. All right, if it was subtraction, it would matter, but it doesn't because it's addition. Keep in mind, this formula, guys, when you're trying to find a midpoint, you need to have an ordered pair for an outcome, not just a single number. So don't do a midpoint and then say the midpoint is 10, because that's nothing. That's just a number. Okay? You can get distances that are 10, but not midpoints. This should always be a number, comma, then another one you need an ordered pair. All right, so that I'll do a few examples here. So we'll do that one that's on 10. So with these that are graphed out, it's going to be a matter of, if you want to do midpoint formula, the one that's here, you need to get your coordinates first. So you got to make sure that you write out your coordinates first for each point, then plug them into the formula. If it's graphed out for you, you know it's there. You can do the thing where you draw the two distances and cut those in half and create a new triangle. If for some reason you like that, I would assume most people are going to pull the coordinates out and throw them in that formula. So the point A that's there, the order pair that goes with it is that's at -2, -3. This one over here should be at 1, 2. It doesn't matter which one you call x1 and y1, and it doesn't matter which one you call x2 and y2. It just matters that you take your two x's and add them together and your two y's and add them together. So if I applied like the midpoint formula, that's right there. My midpoint would look like -2 plus 1 divided by 2, -3 plus 2 divided by 2, which comes down to, so that's -1/2, and that's also 1/2. Yeah, it's like right there. Now, if you wanted to check this, when we do distance formula, they might say something like, verify that this is a midpoint, which would mean you would have to find the length of that segment and the length of that segment. If this was actually the midpoint and we did it correct, whatever numerical value goes here is the same as whatever goes there. Where it says M is the midpoint of CD, and they give you the coordinates for C and the coordinates for M. So they're giving you like one endpoint, they're giving you the other midpoint, or they're giving you the midpoint, and they're saying find the other endpoint for it. The coordinates for C, -1, -1. What's the midpoint? Coordinates 5. So I know like that is half of the entire segment. Okay? So if I want to do my other coordinates, so I'm trying to figure out where the other endpoint would be. If you have a Graph available, again, this would be kind of easier to deal with, but it's not necessary, okay? All that you're doing is, if you're going to use the midpoint formula, you just do it kind of in reverse order as to what we would have done, meaning when I had the two endpoints, you added them and divided by 2. So if you do the opposite of that, you would multiply by 2 and then subtract the number from it, because you're kind of working backwards. So opposite operations would work. Yeah.
1 over 2.
What is?
At the middle.
What? 1 over and 2 of?
Oh, we're trying to find D.
Yeah. Trying to find D. Okay. All right. If I have this graphically, so the point D, since this is in the middle, it's got to be up here. So I might actually run out of room. I don't know how. Maybe not. Okay. Like D can't be over here because that wouldn't be in the middle then. It wouldn't be over here because that wouldn't be a segment. Okay. They all got to be in a straight line together. If you have it graphically, if I count from here to here, right? If I kind of, like I said, create this little triangle again, which is going to be key when you do distance formula, at least start distance formula. And essentially what you're creating here is a right triangle, because this is a right angle, because these are horizontal and vertical lines, which always make a right angle. But if I find out how long this is, and essentially treat this like a slope, getting your next point on a line if you were using slope, it's going to give me where D should be. So how long is that? From -1 to 3. So that's 4. And how far up? 6. That means for me to get my next point, I'm basically going to just copy that up, but I'm going to start with point M instead of point C there. So I would go 4 over and then 1, 2, 3, 4, 5, 6. So my 4 and 6 there, that should be where point D is. So that's one way to do it. The other way, if you're going to use the formula, keep it in mind that like this chunk right here gives you the X for the midpoint. This chunk right here gives you the Y for the midpoint, meaning that this point M, which was that was 3, 5, correct? Yeah. All right, so 3, 5, like this whole number right here is 3, that's 5. You essentially set up equations. So you say like 3 equals x1 plus x2 over 2. 5 equals y1 plus y2 over 2. There's 2 variables there, but they give you one endpoint, which was, what was the coordinates for C? -1, -1. So I can take one of those, put the -1 in there, -1 there. So you take your other coordinates and fill them in. So if you don't want to graph this out, or if your graph's not available, this would be your process to do it. So you would first, in terms of order of operations with solving this, you would multiply by 2 to there, just like cross multiplying. What's 3 times 2? So I got 6 equals x plus -1. What's 5 times 2? All right, plus -1. Oh, what am I writing? Okay, how do I solve that? Add the 1, right? So there's my 7, which is what I got over there. And I do the same thing here. What's 10 plus 1? Oh, good job. Let me tell you, that number 6 up there, that's right. So it should be the -4, 8, right? That one was more straightforward, just adding together. On this one here, you guys know what that word means?
Yeah.
What?
They're
They're all on the same line. Okay, if you ever see collinear, collinear always means that they're points that are on the same line. So basically when they say these 3 places are collinear with each other, that means that you can draw a line that connects all 3 of them. Straight line. Okay? You know what equidistant means?
Nope.
Figure it out. What do you think equa means? Equal and distance is? Equal distance. Okay, so they're equal distant to each other. So that essentially what they're saying is if it's collinear and something is equidistant to 2 endpoints, they're saying that that thing is the midpoint. So the way this reads is they're saying that this Cafe 103, since it's collinear and equidistant, that means that this is the midpoint. So the way this question breaks down, even though they don't use like coordinates like with points A and B, this point right here, the 7, 2, that is the midpoint. And this is one of the endpoints. So the question is essentially asking you to find the other endpoint, just like we did on that last one, either by graphing it out, which obviously you don't probably have graph paper there, or by doing the midpoint formula, where I did like the x for the midpoint equals x1 plus x2 over 2, and the y for the midpoint. So where you're multiplying the midpoint by 2 and then subtracting the other coordinate that's there, the other endpoint. So if I plugged in the numbers I had there, so that was 7, 4 and 6. So x, there's one x coordinates 4. Is it 6? Yeah. 6. Right? And then solving that out. But again, the process essentially becomes directly opposite of what you do here, where you add them and divide by 2. Here you're going to multiply by 2, the midpoint, and then subtract the other one from it. Okay, because that becomes 14 equals x plus 4. So x is 10. 4 equals y plus 6, so y is -2. It's first by going through that thing. You guys familiar with that? Pythagorean theorem? Yeah. And what's it used for? Yeah, to find any of the sides of a right triangle. So like I said before, all this stuff with finding midpoints and distances are kind of related to being able to draw a right triangle in there, where this represents like a horizontal distance and this represents a vertical distance. Your distance formula is related to you finding this side, but when we get to actual right triangles, this applies to any side we want. Pythagorean theorem is based on the sides being a, b, and c, and it's brought up as a squared plus b squared equals c squared. Which we'll get to proving that, which a proof when we get to it you'll see is like a long-winded like explanation on why something is able to be used. There's lots of different ways to prove this. So again, the way you guys are going to be using it is you're going to be finding this side, but knowing the other sides based on coordinates and figuring out how far vertically and horizontally those coordinates are from each other. So for example, let's say, give me a number here.
7.
4? Yeah. Could do that. I don't know. If I wanted to solve, so again, you're just plugging 9 in for A, 7 in for B, or vice versa, and then 1 for C. It doesn't matter which one you call A or B. The only thing that matters when you're doing this is the C, the longest side, better be the one that's by itself. Okay? So I got 7 squared, 9 squared equals C squared. What's 7 squared? It's 49 plus 81. A number is, it's great.
I think it's 130.
C squared. And how do you get rid of the squared? How do you make it just C? The square root, right? Because if it's squared, the opposite is square root. Let's see. I mean, that's fine. I would assume you might get like half the questions being just leave it in a radical form. You might have to simplify them. You might have to do decimals with it. Probably right now I would say either leave it that way or as a decimal, which if you did that as a decimal, what is it? Okay, a calculator, do it. It should be like 11 point, I don't know, 4 or 5, somewhere in there. In terms of distance formula, whatever, this is on page 11 if you're trying to fill in with this. Okay, is you're taking the 2 points that you have, and pretty much doing what I did with that first midpoint, where you draw like your little triangle using like a horizontal distance between them and a vertical distance. So if I connected the two here, I would create a right triangle, and I could, since they're vertical and horizontal, I could just count how long those are. I don't know what the actual questions are.
It's 2, 5,
2, 2. Oh, well, that's where C is. So they want you to call it C. So this one is how long?
5,
5. And that
2,
one.
and then the other one's 5.
Wait, what?
The other side's 5.
What's that? AB's 5?
Yeah.
How do you know that?
Because it's the same distance as C.
Let's see. B. Okay. All right, so the point of them making that point, they told you to put point C at 2, 2, which I did anyway before I read that, is being able to figure out what your two sides of that right triangle are, so you can use Pythagorean theorem to find out the length of that segment, which again works fine if you have it graphed out or if you have graph paper available for you. This works good. Okay, because I can just take the 5 that I have there plugged in, 2 that's there. That's 25, right? That's 4. 29, and then do the square root of that. That's how long it is. Okay? 5.4, we'll say. Okay? So if you want to do it as a decimal set. All right, now, if you don't have graph paper available, the distance formula that you actually have can be used in the same fashion. It's just a matter of distance formula, kind of, if you look at it, takes you down to this point almost right away, but it more hits that fashion if we were to throw the square root there. Okay, because the way that distance formula works is you're going to find out how far apart the x coordinates are, which is what that 5 was, how far apart the y coordinates were, which is what the 2 is, and then you're going to square those numbers. So it looks more complex, where I think they have a portion there. Yeah, if you go to page 12, they kind of have a little section for you to fill it in. So if you're going to write distance formula down, if you forget it, even though it's only Pythagorean theorem, it's just when you write a formula out, you do it general, so you have x's and y's in there. If I were to look at this, the way this 5 works is I understand that it's graphed, and I could just count 1, 2, 3, 4, 5. But in reality, this coordinate here is at -3, 2. This coordinate over here is 2, 4. The way that 5 came about is that you subtracted the 2 x coordinates. So if I took this x coordinate up here, subtracted it from that x coordinate over there, that gets me the length of 5. Okay? Which is how you work distance formula. Distance formula is this number here. This is your x coordinates subtracted. Like subtract. This right here is going to be the y coordinates that you subtract from each other. So if I looked at that 2, the way that 2 came about is you take the 4 that's there, subtract it from the 2 that's right there, and that gets you the 2. Okay, so you can always subtract the x's and subtract the y's to get the numbers that you're going to square in here. The order doesn't matter because you're going to square them, so everything works out good. Now, if you want to write out a distance formula, okay, so again, it's basically I'm writing this portion of Pythagorean theorem out, where you've already found the horizontal and vertical lengths by subtracting some numbers, or like I said, if it's already graphed out, you don't even have to worry about this. But for the first part is you're going to subtract your x coordinates. Again, it doesn't matter what order it's in. The order only matters if you care about the sign. But if you square something, it always makes it positive, so it doesn't matter. and then the y coordinate squared. That's distance formula. That's the whole thing.